Obviously, we have new legislation coming out in 2018 in Europe that will be certainly will have quite some consequences, which is all around privacy by design, privacy by default. There's some penalties involved by breach of data. One of the things is clear is that if you look at the operational data, also first on our machinery, it is not owned by us. It is actually owned by our customers. And in agreement with our customers, we create value-added services around it. I think where you come at this moment in unclear territory is if an employee, for example, on the work site, an operator who runs a machine that is owned by the company, who owns the data at that point in time and how is data privacy related to that? So I think there's a lot of on the one hand, legal and privacy questions that need to be solved. On the second level, if you look globally, we see differences in data privacy policy between different regions in the world, and that is something that needs to be straightened out, particularly for companies that work worldwide.
The other topic is when you are on a production site and you producing some kind of goods. So, and the production process, of course, providing some data about the production and about the product. And of course, in this case, you are speaking about IPs which you want to cover. So you have here other issues that when you have data production and who's the owner of the data, you have to have very clear what is your own IP and of course which is let's say, general available in an open data. I'll give you a third example. When you are speaking about autonomous driving, so and you have some traffic situation on the street, then of course you have the data inside the car, which of course are the IPs of the car manufacturer or the driver of the car, but nevertheless you have to exchange here really some kind of data which have to be available that you have at the end you are able to handle an autonomous driving. Or give you a fourth example, when you're speaking about energy, we have an energy grid where you have producers of energy, maybe huge gas turbines, but maybe also at your home a solar panel or something else, so you are also a producer. And on the other side you have the consumer, like we are in the house, at home, where we are consuming the energy. So to balance this grid, you need a lot of access to a lot of data. So and this all have to be clarified. Who is the owner of the data? What are the IP rights, or who's the ownership? Who has the rights on the data when you're speaking about the production? But which data must be shared to handle this economy? Besides the effect that you have some regulations, some laws to handle this data in a, let's say, in a way where we as industry can make also further business with the use of the data. So we have really some multidimensional topic which we have to discuss. Last but not least, to forget, of course, the data have to be secure. They have to be in the, also discussions about cybersecurity. So you have to take care, and you have to implement methods, the exchange of data, the use of data, and data is the oil of the 21st century when you're using this. Then you have also to have the right method and the right tools, the right systems to protect the data. Besides the effect, who's the owner, what are the regulations of the data, and what is needed to exchange data to handle the different aspects.
Data ownership and data protection is becoming more and more of a discussed topic. There's a national interest, political interest, there's security, privacy interest associated to the data itself. When we collaborate with our customers on the IoT, what we very specifically state is that we provide and we accept and we recognize that customer has the ownership of the data that we're collecting. But we get the approval from our customers to use the data to improve the services and products that we're offering them. I think that's a fundamental principle that we're operating in. In addition to that, what we do is we provide the connectivity for our customers on the plant level. So if they wish to use the data that the crane is collecting to better manage their operations in their own material flow, at their factory level, then they have all the capabilities and all the possibilities to do so. So we provide the open interfaces that allow them easily develop solutions and connect the cranes to their own systems. At the same time, we transmit a fraction of the data external into our cloud solution, and then use that information for the service and for the maintenance of the crane, which is also then fully visible to our customers. So we also feed back all the information that we collect to our customers so they have a full visibility of all the data that is being collected, and also all the other transactions that we're doing together with our customers. So within that same customer view, they get access to the machine data, they get access to the service technicians' data, to the documentation, to the billing, everything, all the transactions that takes place between the two companies. But I think behind all of this is the understanding in the first place when you're developing the architecture on what data you should collect and what data you should transmit, and how you should restrict the accessibility of the data. And that, again, needs to be very carefully thought through before you actually implement it, instead of doing the other way around, learning by mistake. And the mistakes that you do with your own processes and with your own products are acceptable, but mistakes done with customers' equipment and with customers' promises are not. So this is not something you want to do with a light approach, but really put some effort on it.